Okay, so today we have a 2012 A1278 with the customer complaint that it does not power on and does not charge with no green light on the charger. However, as usual with stuff that comes in my office, it seems to magically work when I get it, because if I plug charger in, let's switch over to microscope view here, we notice that the fan spins and we get a green light in the charger. So most likely what's going on, as usual, is we have a intermittent issue on the board. Sometimes when ceramic caps are corroded, they can short to ground intermittently, and sometimes in transit, bouncing around could cause them to work for a short amount of time again and then die again shortly after. I've seen this a few times, but it's usually the case. Sometimes stuff is weird. Some stuff may only present itself at a certain temperature as well. So let's take a look through the board and see if we can't see anything that might be causing our issue. So switch over to microscope view again. I have a better C-mount adapter on the way too. It should be here January 3rd, so that should help out. So starting by the SMC area, notice it doesn't look bad. There's no corrosion. Have some corrosion on that Thunderbolt cap, not a big issue. Water hit the edge obviously. LCD area looks good. Keep going up. Have some corrosion right here. More liquid right here. You can tell it came in through around near the port. Pretty typical. And we have this mess. And I bet one of these caps is for PP3V42, which is probably going to be intermittently shorting to ground. My guess it's going to be, let's see here. My guess it's probably going to be this one. That one looks pretty messed up. Or this one. It's going to be one of these, I bet, that's intermittently shorted. So let's keep going. Let's look at our ISL area. ISL looks pretty decent. Does not look like there's any corrosion there. So that's out of the question for causing an issue. Well, not necessarily, but most likely it's not an ISL issue. We have a little bit of flux right here. I don't know if that's factory leftover. I don't think so. Maybe, I don't know. Maybe it was an Apple reefer board that they messed with. And look at this. So what this is going to be one of our sensors. So I bet if we run Apple Service Diagnostic that we are going to have a sensor code, because this is no good. This is just destroyed. And let's flip it over. I bet we're going to have some similar damage on this side, probably under that heatsink. Can't really see that, but there is a little bit, but nothing too significant. Nothing that would concern me. Nothing by our CPU MOSFETs, that's good. Clock circuit's nice and clean. Nothing around the PCH. 3V42 circuit, which is going to be right here, that looks good. Nothing over here either. Sometimes these caps can corrode, and if they're short, that'll pull down PP3V42, but otherwise this looks pretty good. So there's really not much to check, unless it's a battery detection issue, because liquid was near the SMC. So let's check voltage on PP bus G3 hot real quick and see if it's at 12.21 or 12.23. I don't think so, though. I think this is more of just an intermittent issue, or corrosion under something that's causing intermittent issues, but let's see. So let's see what PP Best G3 Hot is measuring. Let's see, this is going to come up on the screen. And it looks like we are at 12.3 volts, which that's not going to show on there, and that's pretty noisy. I think that's because my lead isn't grounded well. Let's ground the lead better. Measure one more time. And we're at 12.3 volts, which is a bit too low. Let's have a closer look at that. Shows on my scope, but not on the computer very well. But that's a little bit noisy for BP Bus G3 Hot. That's not out of the ordinary though. Wish the computer would show it, but let's switch over and I'll show you what I mean about noisy. Alright, so see if I could move that without dropping anything, but that, I guess that's borderline normal. And now it's back up to 12 point, it's going between 12.4 and 12.6. So most likely we have a little corrosion under the SMC that's doing that. Wouldn't surprise me, and that would explain the intermittent no green light in the charger either. So let's see if we can see it. Okay. Move the microscope over here. Hopefully I don't rip any cable out of the computer. That wouldn't be good. Alright, so we can't really see much under there, but we don't really have a good view either. There's probably some stuff under there. We'll take the edge bonding off and give it a little light reflow. Okay. So I'm going to get started here. So the first thing to address is we're going to run Apple Service Diagnostic and see if we come back with any sensor errors, and I bet we will. Maybe it's just being sent in for that. Maybe there's a communication error. And let's see if it's pulling any sensor errors. Okay, here is Apple Service Diagnostic. Going to run the sensor test. Let's see what it comes back with. ICOR is reading above the high limit, so I'm guessing that's going to be our one issue. So next we're going to go over the ICOR circuit on the schematic and then on the board and see how that area of the board looks. If we go over to the schematic, we see that ICOR is for CPU high side current sense. We see it's a relatively simple circuit. Then we see U5410, which is our chip that was messed up. Now notice Apple Service Diagnostic did not see that this chip was reading improperly. However, what are we going to trust? The chip that looks completely clean or the chip that is corroded and falling apart? So let's have a look at both of these areas on the board right now. Okay, and in front of us right here is going to be U5410. Or U5400, my mistake. So this is U5400. This is the chip that is supposedly failing Apple Service Diagnostic. However, if we go over to our U5410 chip, we see it is completely falling apart, as you saw in the beginning of the video. So let's measure outputs from both of these chips, and let's see if we can figure out what the sensor above the high limit means. Okay, so here's the measurement on our U5400 chip, and this is the output that is supposedly reading above the high limit, and you see we have 108 millivolts, and this is our SMC output. So this chip is going to basically talk with the SMC and report a value in millivolts back to the SMC on the approximate voltage on that rail. And I don't really think this is reading above the high limit, so let's go ahead and check our U5410 chip, which is the one that is corroded and falling apart. And on our corroded and falling apart chip, you can see that we're basically passing PP3V3 SO right to the SMC. Now this, I believe, is where our sensor above the high limit is coming from. So I believe this is the first issue that we need to address and see if that goes away. So the first things first is go grab a donor board and go ahead and replace this chip and figure out what's corroded under this via. Possibly we'll have to run a wire to the other side of the board, but we're going to handle that in 1 second. it's soldered. Now you notice that this via right here does not look very happy. It just looks like it's corroded and falling apart. And I don't think that that's going to pass its... Where'd it go? Come on. Alright, I don't think that via is going to pass its electrical signal to the other side of the board. So let's figure out where that via goes. Go back to display capture, go on the board view. We notice that is going to go on the other side of the board, of course, under the heatsink to R5410. We'll run a wire there in a second. But first of all, now that that's soldered, let's see if we have any change in our reading. So let's put back on window capture. Grab our oscilloscope probe. First, let's plug the board in. And no change yet. So let's run a wire, complete that circuit. Maybe it's not going to switch or start sending good data to the SMC unless it has that connection. So first things first, let's pull off the heatsink because we're going to need to get under there. I feel too lazy to walk over there to get the proper screwdriver set, so I'm going to use this giant one. Should work good enough. Whatever, I'll get my... Any of you guys get that too, where you just want to use what's in hand's reach and don't want to get up to go get the proper tool? This would be probably quicker rather than dealing with a tool that doesn't work right. Okay. Back to microscope view. See, here's our resistor that we need to run a wire to. Notice we have a little bit of corrosion right here too. That's nothing to worry about though. That little tiny bit that'll come off in the ultrasonic. And what is this? That's weird. It's like a hair or something got stuck in there. Oh well. So we have to go ahead and run a wire from pin 2 to one side of that resistor. Jumper wire. A little bit more flux right there. I'll scrape off a little bit of the coating, but not too much, because I don't want it showing the pin right next to it. Now that that's tacked down, I'm going to maneuver the wire a little bit more. Just like that. Perfect. Can't wait for the new C-mount adapter to come here. I'm sick of having to move the microscope into view. There's our wire. Let's plug it in and let's do our same measurement. Let's see if it changed any. I don't think it did. I'm almost starting to wonder if the communication to the SMC is skewed from corrosion. I have to do this quick because there's no heatsink on it, and it's likely going to thermal trip fairly shortly since it's an IV bridge. This microscope, this oscilloscope software from Rigol is really, really lousy. Every time you change the setting on the scope, you have to close the software and reopen it, or else it won't change the scale. Of course, there's a possibility I'm just being an idiot and there's a way to do it that I don't know about, but I'm not sure that there's a way. Just seems like pretty lousy software. Yeah, look at this. I'll show you guys. Oh, now it decided to work. Alright. Window captures up. Clip the lead on. Now we get no fan spin. I think that's because... Alright. What did we do? We run our wire to the wrong place? Because now we get... Let's see. What did we do wrong? Oh, there we go. Kind of odd. Probably random corrosion under the SMC. Now we notice that we don't see that on our scale, so that means that it must be reading lower than that. So we close the software and change the setting on the scope so that I can show you guys, because the software will not allow me to change that. Okay, now let's try this again. And now you see we're reading nice and normal at around, it's going up and down because it's talking to the SMC, but it's around millivolts, so we're not passing 3v3 SO right on to the SMC anymore, so I bet our sensor error is going to be solved. So I'm going to put this in the case, and we're going to see if this works and passes Apple Service Diagnostic on the sensor test. Okay, let's try this again. And all tests pass. So let's scroll up and see. Actually, let's go to hardware profile and let's see if our ICOR sensor is reading normal. Let's find it here. This is pretty lousy user interface here, so temperature. You'd think they would allow you to scroll with this, but this does not work. You'd expect something a little bit better, but nope, not from Apple. Alright, so we have, that's Thunderbolt, we don't want Thunderbolt. I don't want battery. Magnometer, I don't really care about that. Accelerometer, don't care about that. Battery current. IO0R, which is our chip that was messed up, is reading normally. About 1/10 of an amp, sounds about right. And where is, come on, ICOR, it was ICOR or IDOR, I don't remember. But either way, so ICOR is right here, which the high limit is 17.4 amps. It was reading 17.4 amps before because that line was open and it was just misreading. And if we see now, we have 0.75 amps, which is perfectly healthy for a CPU that's currently running in EFI. So all looks good there. Now we're going to go address the other areas of corrosion on the board. So what I'm going to do is basically just pick out this whole area. Can't trust any of this being left on the board. Go ahead and get rid of all this. I'm going to use the wick that already has some solder on it to kind of get rid of that lead free, and then I'm going to, just easier than putting fresh leaded down. Now wick all this away. Missing pad right here, I think. Maybe not, just corroded. Yeah, just corroded. That'll come back. Clean up all this junk from the wick. So this right here, we're just gonna scrape a little bit. And there's no reason why this won't touch up nicely. Now we're going to clean this up a little bit so it doesn't look like it was soldered by a monkey. Or worse than a monkey. In all reality, it doesn't really matter. Fixed is fixed. That area looks pretty good. Next thing we're going to do is give the SMC a little reflow, because intermittent power issues as well as corrosion right in this area usually means our SMC probably has some junk under it. So to remove edge bonding, what a lot of people do is heat the chip at 100 Celsius to take the edge bonding off. I've been doing something a little bit different. What I have been doing is giving the chip a quick blast of 430 degree air and then taking it off. So I'm going to show you guys right now. Just like that. We don't want to make it hot enough so it's brittle, and the edge bonding should come right off. See that? No more fighting with it. Sometimes at 100 Celsius it comes off in bits and pieces and it's just a mess. But hot and quick seems to be a good way to do it, at least that I found. So what we're going to do is get some flux around this chip. So if you remember earlier in the video that the board didn't power on one time, most likely it's due to corrosion under the SMC. It is very common, and a lot of times you can't even see it. And that's it. Just inspect to make sure I didn't miss anything. I don't think I did. I think all is well. That area looks good. That's wire's going to get conformal coat after ultrasonic. Oh yeah, let's get rid of this cap. I don't trust that cap. Get a little bit more solder on this side. And this tip is starting to die on me. We made it worse. Trying to make it pretty, made a mess. That happens though. You know what's funny is whenever you don't want a blob, that you'll always make one, but then when you want to bridge something without having to run a wire or something, you're gonna make you'll never be able to create one. good enough. Alright, let's make sure we didn't make it worse. I don't think we did. Alright, green light, of course. And spinning fan. Okay, so this one wasn't what I expected. I was expecting it to be a 3v42 short or something, but the issue seemed to be intermittent. I think it's solved. It was probably something in that one circuit that was all corroded. But as a board level technician, you're going to get some jobs that are intermittent in nature. They're not going to present, the issues aren't going to present themselves every time. And what I found by experience is you could do one of two things. You can either get it, not look it over until the customer works and send it back. If you do that, they're going to be back very shortly, or they may just go somewhere else. Always give the board a really good look over and make sure that there's nothing corroded. You know, sometimes people are going to send some weird stuff to you. I get sometimes people will send something prepaid, of course, and they'll say, you know, well, sometimes it doesn't turn on, or sometimes you get a line in the screen, and it's not a, you know, those kind of issues. Those just, you know, you're not really gonna be able to trace those down. But for the most part, give the board a look over. Oftentimes with intermittent power issues, you're gonna find one little corroded cap somewhere, and that corroded cap is gonna be shorting the ground, you know, based on temperature or something like that. So thank you for watching, and I'll see you in the next repair video.